Hey there, grade 5. This is Mr. B. Today we're going to be learning about elapsed time on timelines. So these, as you can probably see, are like number lines, and we've worked a lot with number lines throughout the year and through many years of school, I believe. So we're just going to very quickly review how you use a number line. So let's just say this is my start here, and I'm going to start this one at 5. And I suppose we could go all the way over here for this example and make this 12. The question would be, how much time is between the 5 and 12? And what you can do to figure this out is you can just do little jumps, right? So you can go make a 6 one, a 7, an 8, a 9, 10, 11, and then, we don't need that. So, and then you can just count how many jumps it'll take. 1, 2, 3, 4, 5, 6, 7, right? So 7 jumps. And so to get from 5 to 12, you'd require 7 jumps. Now, if you wanted to do this with math, the way you could just figure it out as well is to go 12 minus 5, and this would give you the amount of time between these, or the difference, right? So we sometimes talk about the difference between times, right? So this would give you the difference, and that would be 7, right? 12 minus 5 is 7, and you can, anyways. Now, today we're going to be looking at how time can also be worked on in a similar way. So 5 o'clock instead, and let's make a 12 o'clock over here, just for our example. Now, how much time do you think is going to be in between these two? Well, if you guessed that 7 hours would be between these two, that is correct, right? So we can do it again. We can just skip we can skip putting in all the ticks, but we can count it in our heads. So we could say 6 o'clock, 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock. So just by counting, right, we did this. So this was 6, 7, 8. So we could put the 8 here, I suppose, just to 9, 10, right? And then we got 12 o'clock. And again, it was 1, 2, 3, 4, 5, 6, 7. So in this case, it's 7 hours, right? So you can see how timelines can be used just like number lines. So that was a fairly easy one. What we want to do now is to show where it's actually kind of useful, right? So in that case there, we could have done that just with simple subtraction, but we want to figure out where can this strategy of using number lines be helpful. So let's have our start time. We're going to say our start time is, well, let's just write it up here. Start equals 3:52, and then we're just going to say end equals 5:10. So when we see a start, we're going to put the start here, right? We're going to put a start right there like that, like so. And we will put it here, 3:52. And then we put our end over here. And now you don't always have to put it on the far end. If you wanted, you could just put it here and save yourself some space. But for our purposes today, we're just going to put it over here. And what you do is you can just put the line wherever. And as long as you have a big line like that and a big line like that, and it'll signify the beginning and end. And mostly, remember, this is for your own sake to perform the math. So as long as you can read it, and in the case where I'm marking it, you want me to also be able to see it, that is what's important. So here we go. So what's our first thing that we want to do to figure out how much time in between these two? Well, the first thing that we might want to do is to get this to an even hour, so straight on the hour. So what's the closest hour that we can go to if we're going in this direction, right? What's the closest hour? Well, it's going to be 4 o'clock, and we could say the 4 o'clock is around here, and you don't have to be like precise or anything. So let's just say this is 4 o'clock. And the reason this would help us is because then we can go by hours instead of just minutes. So, because we don't want to go up by, we want to get to 4 so we can jump by an hour all the way to 5. So how many minutes would be here? Well, this would be 8 minutes, right? Because you need to get to 60, right, to the next hour. You're going to need 8 minutes more on that 52. So it'll be 8 minutes to go here. And then we can come up here and say this is 5 o'clock, right? So this is 5 o'clock, and we would say this is 1 hour, right? 4 to 5 is 1 hour. And then we can do another little segment, and this is 10 minutes, right? And there we have it, right? So you see how all this works. And now we've made it there with our jumps. And now all that's left for us to do is to add all these up. So what we would like to do is collect our minutes together and hours together. In our case here, we only have 1 hour, so we just put the hour there, and then we put the minutes together. So it's going to be 8 plus 10 minutes, right? And this will give us 1, and we can write it like this, 18, right? 8 plus 10, 18. So that would be our amount of time elapsed. So this is how you can figure it out using this. And you just kind of collect all these things once you've done the little jumps and hopped your way over there. Like a little bunny rabbit, you do a little hop and a little hop, and then you're there. So this is just a way of breaking it down and figuring it out. So instead of having to do all the calculations, you can just kind of hop, make little easy hops. A little nice red hop here. So just 8 minutes. Then you do a nice 1 hour one, and then a 10-minute one, and that can help you figure things out. So let us think here of another one with, we'll call this girl Solveig, and we'll say the start time this time is at 11:45, 11:45, and then it'll go to the end time of 3:11, end time of 3:11. Now, if we were doing regular math, this would either be PM. These would be in different categories, right? Because if it's going towards that, it would be in the next hour. So we would probably want to change this to like 24-hour clock, which would be 15:11. And that would help us to better understand what is going on here. So what we're going to want to do, right, is come here and make our start time 11:45, right? 11:45, and then our end time all the way on this side, we're going to make it 15:11. Technically, when we're doing this jumping thing, you can keep it in the 12-hour time, but I always find it easier if you just put it in the army time, because then you're just counting up and you don't have to have a reset partway through, right? So 11:45. So what's the first thing we want to do? Normally the first thing you want to do is get this number up to the nearest, like, just even number. So when I say even number, I'm thinking like 7 o'clock, 8 o'clock, 9 o'clock, 10 o'clock, 11 o'clock, 12 o'clock, 13 o'clock, 14 o'clock kind of thing. So for 11:45, the closest just hour on the dot, right, is 12 o'clock. So we have to get to 12 o'clock. So this will be our first jump, and normally that'll be kind of your first jump that you'll do. And here, to get to 12, well, we know there's going to be 60 minutes, so we can sometimes, if we don't know this exactly, what we do is we will check. We know there's 60 minutes in an hour, and we can subtract 45, and this we'll need to have this. It'll be 10, right? And then you'll get 5 and 1, and you'll see that it's 15 minutes. Now 45 in particular, is one that you should try and kind of remember, right? 45 is 15 minutes away from the hour, and that's why we say quarter to, because if you remember clocks, they have a six, not a six there, oops, a 3 here, a 6 here, a 9, and then you have the 12. And so this is the first quarter, this is the second quarter, this is the third quarter, and this is the fourth quarter, right? And so this one is 15 minutes, this one is 30 minutes, and this one is 45 minutes, and this is 60/0, right? Because it resets. So we would say this is quarter to, right? Because it's 1 quarter away from the next hour, and a quarter when you're dealing with time is 15 minutes. So this one we should be able to just recognize without having to do any other math, that'll be 15 minutes away, right? 15 minutes. Okay, so now we're at 12. Now we can make some big jumps. We could, if we wanted to, go just to 1, right? Well, we could make a bigger jump, make it a little bit bigger than that. We can go to, 13 o'clock, and then we could go to 14, and then we could go to 15. But I think there's a better way for us to do that. So that's option. You can do that and just jump, but then you're going to be a little bit more work. So to get 12 to 15, we know that we're going to have to do 3 hours, right? That's going to take 3 hours. The difference between 12 and 15 is 3, right? So 12 o'clock and 15 o'clock, the difference will be 3 hours. So what we can do is make a big giant jump, right? And say that this is 15 o'clock. And then it took us 3 hours. Now it's fine if you want to do it this way. That's totally okay. 13 o'clock, 14 o'clock, and 15, right? So if you really want to do it that way, where you have your breakups there, that'll be fine. So yeah, you just make sure that you, in this case, right, you're gonna have to remember to gather these up. So this would be 1 hour jump, 1 hour jump, and a 1 hour jump, and at the end you're gonna have to gather these together. This way you won't have to gather them together, which is a bit nicer. And then last 15 to 15, 11 minutes past 15 o'clock, that's going to be 11 minutes, right? I think that's pretty straightforward, that 11 minutes past 15 is 11 minutes. So hopefully you get that the minutes past here is just, you just kind of add that. Once you get to the even number, it shouldn't be that hard, and we had the same thing up here. So as long as you generally get the principles of the clock, this one should be fine. And now what you do, just like before, we're going to gather up our different ones. So if you were here, you would gather your hours into 3 hours, or if you're on the bottom, you just have to gather your minutes. So you have 3 hours, and then we have kind of our minutes over here. So we have 15 plus 11, and that's going to equal, right, 3 hours and 26 minutes, right? And so there's your answer, and that's how you can use a number line to help you figure that out. Okay, so jumping on to our next question here, we're just going to look quickly at finding an end time. So let's just say Sarah or how about we'll say Laurits, another great Viking Danish name, Laurits. He starts climbing, you know what, let's make it more fun. He starts marauding an Irish coast with his crew, and he starts at 6 in the morning, at 6:57. Let's say that's his start time, right? We'll say start. And let's say he knows that the Irish chief nearby will respond in about 25 minutes, right? So he knows that there's going to be 25 minutes. So this length, the total length, is going to be 25 minutes, right? From here all the way to here. So he's going to know that that's going to be 25 minutes. So what we have to do here is we're trying to figure out, well, what time does he have to be gone, or what time is the Irish or the Irish army is going to start arriving. And so yeah, that's kind of important for him to figure out. So what we want to do first is we're going to break this 25 minutes up. So for our first bit, right, one of the things we always like to do is get to the hour, because then we can add the rest. So we just see here, 6:57. We're going to go right there, and we want to get to 7 in the morning. So what's this hop going to be? Well, it's going to be 3 minutes, right? So 3 minutes. Now, that'll mean that we've hopped 3 minutes. So we've hopped 3 of the 25 minutes. So now what's remaining is 25 minus 3, which equals 22 minutes. So we have 22 minutes left. And so 22 minutes on past 7 is going to be, right, this is going to be our 22-minute jump. And then this time, we'll know, is going to be 7:22, right? 7 o'clock plus 22 minutes is going to equal 7:22, right? So that's how we can find end times if we know the amount of time elapsed, right, on this timeline. So I hope that one's pretty straightforward. I'll do one more with you just to clarify this. Just to make sure that you're getting it. So here we're going to just start. So this is a different raider. Maybe this is Leaf. Leaf is coming, and he starts a bit later at 7:52, right? And he knows where he is attacking is a bit more out of the way. Even though it's a bit later, maybe people are a bit more ready. It's a bit more out of the way. And it's going to take 30 minutes for the men of Northumbria to arrive, right, and fight him back. So he knows he has 30 minutes to get in, raid whatever he wants to raid, and leave. So this is kind of his game plan, and so it's really important that he knows what time he has to leave at. Even though he probably didn't have a watch, so he was guessing anyways. But for the sake of it, this Viking has a watch. So what we know is we're going to have to go all the way over here. So this time over here is going to be 30 minutes past that time. Well, again, what we want to do is we want to get to the nearest hour. So the nearest hour from 7 going this way is 8, right? So 8 o'clock on the dot. So what we want to do is we're going to jump our 8, and this means, again, that this now is 30 minus 8, because we've used up 8 minutes to get to 8 o'clock. And then that's going to equal 22 minutes, right? 30 minus 8 is 22, just like 10 minus 8 is 2, right? So we're going down to 22, so we have 22 minutes left, and again, just to show this, right, 22 added on to 8, like on the dot, is just going to put the 22 basically right in that block there, 22, and so we're going to have the end time of 8:22. So yeah, our Viking Leaf is going to have to be out of there by 8:22 if he wants to avoid the wrath of, I don't know what his name would be, Adelsted. Maybe that's the name of the guy in Northumbria, even though that's the name of the king in Wessex. We'll call this guy, he's Athelstan the Lesser. So yes. Anyway, so that helps, right? So this is a good thing to be able to figure out using timelines. Finally, we're going to think about the big thing that timelines are helpful to figure out stuff with. So what we can do here is we're going to look at when you have a situation where you have multiple different intervals. So we're going to have this guy, Sigurd, and that's what Siegfried is called in like Norse languages. So Sigurd, and he fights a dragon, I'm just going to draw a little dragon, you know, rawr. It's like a hippo almost. He's got to be breathing out fire. Yeah, that's a terrible dragon. Okay. So he fights a dragon for 10 minutes. And then he fights a big worm, a giant worm, that has big monstrous teeth. I don't know if you've watched The Mandalorian where that big worm, it's kind of something like that. Maybe he fights that for another 3 minutes. So 10 minutes and now 3 minutes. And then he fights finally a bunch of skeletons. How I'm going to draw skeletons, I don't know. I guess they've got their ribs. Yep. So he fights a bunch of skeletons with their shields for another 15 minutes. How about? So what we're going to want to do here is just add these together. So we know that he starts. How would he starts this? He goes into this cave, this magical cave, and he gets all the way to the treasure room. And he gets there at around 10:35, and we want to know what time does he escape. So this fighting is what it takes for him to get out of the cave. So he gets what he wants, and then the dragon, he has to fight the dragon to get back, and he has to fight the worm as well, and then an army of skeletons. So what are we going to do first? Well, one temptation would be to add the smallest one, the 3, but it would be better for us to add 10 minutes, do the easier ones first, right? So 10 minutes added on to 10:35, right? What would that give us? Well, 10 minutes is going to just change that one, right? So, and this is only minutes, so we're mostly focusing on the minutes unless we go over. So this would be 10:45, right? So 10 minutes passed, right? Would make us at 10:45, and then we have another one. We'll do the 15 where he fights the skeleton warriors. So 15 minutes, and 15 minutes onto this. Remember, this is a quarter, so we can also do the math, right? 45 plus 15, you're gonna get 0 and then a 1, and then this will be a 6, which will just be another hour. So this will go to 11, right? If you get a 60, it's going to be 11, and that's the last quarter. And then you just have the 3 minutes left. So I guess this will be our end time this time. And that'll be 11:03. And that's our answer, right? This is when he gets out of the dungeon. So if you were, I don't know, Sigurd's friend waiting for him at the edge of the cliff, if he said it's going to take me about this much time, and you're waiting there, this would be kind of around the time when you expect good old Sigurd to come racing out. So that's a really useful way of using timelines to figure out, how much time or what the end time will be if you get multiple iterations like this. Now, our final kind of thing that we want to look at here is there's another way. Sometimes if you get all these different times, it might be kind of annoying to do it all like that. So let's just think of, I don't know, this person's name will be, let's just call her Gertrude, and she eats breakfast for 18 minutes. So this is her getting ready in the morning. Eats 18 minutes, brushes her teeth or her fangs for 3 minutes because they're big long fangs, so it takes a bit longer. She gets dressed, so I'm just abbreviating as dressed, and that takes 14 minutes. And then we have packing her bag, so packing, we'll just say pack, and that takes 7 minutes. So this is how this is all the time that it takes her to get ready in the morning. So we'll just put some M's here. Oh, maybe we should say min, so we don't get confused with meters. So she takes this time. Now, one thing to do, we could have our number line and we could, skip along. Or what we can do is add all these up, right? We can take all these and we can add them up. So what I like to do is normally I try and just take them in bits, and so that's 21. And you plop these together, and that's 21 as well. And then you can add these together, and that'll give you 42. So that'll be your answer. And now instead of having to do all the little hops, what you can do is you can come back here, because we still have a timeline over here, and we can say he starts, maybe if we're trying to figure out what time it happens, say she gets up at 7:15. Well, now we know we can do it like this, where we know the full amount of time elapsed, which is nice, 42 minutes. And we can just start doing this. So how many minutes would it take for this one to get up to 8 o'clock? Well, it's going to take more of 45 minutes. So we actually know that this is not good. We can't do that. So what we can do now is we can just break this. We can just break this up, or we could just add 42 to 15. And in this case, it's probably just easier to add 42 to 15, because this is a pretty, you don't even have to regroup here. So this will be 7 and this will be 5. And so what you'll end up with is you can just draw this little line all the way to the end, basically. And you can say the end time is 7:57, right? And you did that by just adding it. So yeah, with all these things, addition can sometimes do it just as well. But it's nice to have these handy tricks. Anyways, guys, I hope you enjoyed today's lesson. I'm trying to keep them coming rolling out so you guys are kept busy. But anyways, have a good rest of your Tuesday. Cheers then. Bye.